And the correct answer is coal. Coal is a fossil fuel, so it is a non-renewable energy source. Therefore, it does cause air pollution as they burn those fossil fuels. Solar, wind, and geothermal energy are all renewable sources and don't create that air pollution. Here is our scale for Unit 1. Go ahead and jot down where you are today on this scale in your notebook. Hopefully you are moving up this scale and feeling more confident about how to design a method to monitor and minimize human impact on the environment. We have a article from the New York Times newspaper. So this is an article that has happened in the past. I'm going to put a link to this article in your lesson. So look in lesson 1.07 and you'll see this article. What I want you to do is pause this video, read the article, and then use your science notebook to write one reason that the coal industry is suffering. Now let's talk a little bit about nuclear power. These buildings that you see here in the picture are generating electricity from nuclear energy. So nuclear energy power plants, such as the one you see, are controlled by chain reactions of uranium isotopes, and they convert nuclear energy to heat energy. So this heat energy from the reaction produces steam in boilers. In turn, the steam drives turbines that produce large quantities of electricity. 1 kilogram of nuclear fuel can produce as much energy as 2 to 3 million kilograms of coal. So you can see that 1 kilogram of that nuclear fuel produces as 2 to 3 million. So that's a big difference, a big difference between the coal and that nuclear fuel. So what happens in a nuclear reaction? So we know that nuclear energy is produced by this reaction. So how does that happen? So the atom contains a dense center called the nucleus. So we studied that at the very beginning of the school year when we talked about cells. The nucleus contains protons and neutrons. So uranium is a metal that has 92 protons, and depending on the isotope, from 138 to 148 neutrons. A high number of protons causes the nucleus to be unstable. As a result, a uranium nucleus has a chance of either emitting a particle or splitting into two roughly equal parts, plus some neutrons. The emission of a particle from the nucleus of an atom is called radioactivity. So what we just talked about is radioactivity. The splitting is called spontaneous fission. So that was a lot of information and a lot of big words. So let's break that down a little bit. So we said we are talking about radioactivity. Make sure to put this in your notes. That is one of the words that you will need to know to be able to understand this nuclear energy. Now, radioactivity is the emission of a particle from the nucleus of an atom. The emission of a particle from the nucleus of an atom. If you look at the diagram here on the screen, you can see the radioactive alpha decay in this atom. So over on the left, you see all the big ball that is made up of the small blue and red balls. This is a very heavy and unstable element. So this represents uranium. So this here is uranium. So as we were talking about, when we see this particle that is separating from the nucleus, it begins to have this spontaneous decay. Um, you can see here over on the right, the blue represents the neutrons, the red is the protons, and the black is the electron. Okay, so due to the decay, 2 protons and 2 neutrons are emitted. You can see that over here. They're emitted or removed from the big unstable element over here on the left. So in this case, uranium-238, it decays into something different called thorium -234. So when this happens, this is called radioactivity. What is important, because I know this can be really confusing, and you will learn more about this as you get older, but what you really need to remember is when this radioactivity happens, this is what creates that nuclear energy. Okay, so when you have the big element and there are particles being emitted from this, it creates radioactivity. Now remember, we talked about there were 2 things that could happen, okay? Radioactivity that like we just talked about, or we said that nuclear fission was the other option. So if we're talking about nuclear fission, then we're talking about this um, uranium, and it is now going to begin to make a spontaneous fission. So this diagram you see here is showing you how this happens, okay? Okay, so you can see we have a neutron here on the left, and you can see the red arrows showing us which way this is moving. We see the nucleus here, and it's splitting. It's splitting the neutrons and into a new nucleus, okay? And it just keeps splitting and creating more and more of these nucleus and neutrons until we have this spontaneous fission. Here you're going to see some nuclear reactors. So these are the things that you would see inside that nuclear power plant. These are the tools that change that water or whatever they're using into that nuclear energy. So the boiling water, over here on the left, the boiling water reactor. This is an enriched uranium, produces a continuous source of energy through a chain reaction that is controlled by control rods. And if you look at the picture, you can see these little black rods here are the control rods. The energy boils water to create steam, which powers a turbine that turns a generator, and then it produces electricity. Okay, so you can see down here at the bottom where it's blue is where the water is in the pump or in the reactor. It heats up and controls there, and as it heats up, then it starts to move through as steam and goes through this turbine and creates that energy. And then we then use that to power our homes. Okay. Over on the right, you see a pressurized water reactor. So it works a little differently, but again, this is just using pressurized water. Um, it just doesn't boil the water, okay, where the boiling water does. It's isolated from the reactor core and it becomes it has a second loop. So if you look there at the pictures, you can see how that reactor is a little different than the boiling water. There are some disadvantages to nuclear energy or using nuclear energy, and I have some of those listed there. It does give off radiation. It's a non-renewable energy source, so once it's used, you cannot use it again. It has huge building costs. So as you can see, those big power plants are very expensive. The nuclear power plant is a dangerous. It's very dangerous, and so there are accidents that can be harmful to the people who are working there, and the transport of fuel and waste can be costly. So there are some safety precautions. So people who are working in these nuclear plants, they are very well trained, and the processes in a nuclear power plant require careful monitoring so that safety is kept at a high priority. So all parts are kept in good repair. They got to make sure everything is good and working. Safety systems are built into these power plants, and their processes are very, very carefully monitored. So, nuclear energy, that is a big concept. To really think about how this nuclear energy is created, and it really can it's really a scientific um, opportunity for you to learn and grow in as you go through the rest of your science in seventh and eighth and high school. You're going to learn more and more about how this energy is performed. So just work on getting some of those basic concepts. We are going to complete 1.07 and 1.08 this week. So make sure that you take your time and complete both of those lessons. Thanks.